Look at this question then. Typical exam paper question. Question says, find an approximation for the expression sine 3 theta over 1 plus cos 2 theta when theta is small. Okay, so you're told that theta is small, so we're going to be able to use the usual approximations that we've talked about in previous videos. So this here is going to be approximately the same as, now sine of 3 theta. Well, if theta is small, if you think about it, if theta is small, 3 times theta will also be small. So that means that the sine of 3 theta is going to be approximately the same as 3 theta. Divided by 1 plus, now if theta is small, 2 theta will also be small. So you've got cos of a small angle. That means it's approximately the same as, put this in a bracket to show you, 1 minus the angle squared over 2. So this is 2 theta. If you square it, you're going to get 4 theta squared over 2. So this is 2 theta squared over 2. I'll do it at the side. 2 theta squared over 2. So it's 1 minus that, which is 1 minus 4 theta squared over 2. So we get to there. So this is approximately the same as, okay, so on the top you've got 3 theta over, and then just simply work out 1 plus, well, it's just, you can ignore the bracket if you like, because it's like having one lot of the bracket. So it's 1 plus 1, which is 1 plus 1 is 2, and then you've got take away, and this cancels to being 2 theta squared, like so. Now, you're not told that if theta is small that you can ignore theta squared completely, because remember, if theta is small, then theta squared will be even smaller. If you think of a small decimal like 0.01 and then you square it, then you're going to get 0.0001. So it gets really small. So in some questions you'll find that they tell you that if theta is small, you can ignore theta squared altogether. In other words, cross it out and replace it with 0. But you can't in this question. It doesn't tell you that. So what you've got to do is leave the theta squared and the theta in the answer. So we've got approximately equal to 3 theta over, and now do a common factor, 2 lots of 1 minus theta squared on the bottom line. So for small angles of theta, that expression there is approximately the same as that expression there. And you can't ignore the theta squared here because you're not told to ignore the theta squared. You must leave it in the final expression. That's the end of this little video.